Hi, I'm really excited to show you demo of a cool feature of WoolyAI GPU Hypervisor, where we separate user space machine learning workload execution from the GPU runtime. What that means is, machine learning engineers can develop and test their PyTorch, VLLM, or CUDA workloads on simple CPU-only infrastructure, while the actual CUDA kernels are executed on shared NVIDIA or AMD GPU nodes. But first, a short overview on WoolyAI GPU Hypervisor technology. We built WoolyAI GPU Hypervisor to transform how machine learning workloads run on NVIDIA and AMD GPU. It delivers three big benefits. Unified containers run the same CUDA containers on both NVIDIA and AMD GPUs with no code changes. Separation of user and GPU execution space. Your machine learning containers can run remotely on CPU-only infrastructure, while GPU kernels execute on the hardware. Dynamic GPU resource management. WoolyAI does fine-grained allocation of compute cores and video RAM on GPU across concurrent workloads to maximize utilization and eliminate waste. In practice, this means more workloads per GPU. So, how does WoolyAI bring it all together? The WoolyAI client container runs your PyTorch projects or inference apps like VLLM on any CPU-only node and sends CUDA kernels represented as WoolyAI instruction set to the GPU nodes running the WoolyAI Hypervisor. On the GPU nodes, WoolyAI Hypervisor just-in-time compiles them to the native NVIDIA or AMD instructions, with hardware-specific optimizations. This architecture cleanly separates the user space environment where developers build and test PyTorch, VLLM, or CUDA applications from the actual GPU runtime execution. In practice, that means you can develop anywhere on CPU-only machines, while your CUDA kernels are executed efficiently on shared GPU nodes. The existing way to give multiple users access to GPUs is by spinning up a Jupyter Notebook, a PyTorch container, or even a VM that's tied to a specific GPU. The problem is, each of these runs directly on the GPU host and locks onto one GPU exclusively. So even if that user's workload only uses 30% of the GPU, the entire GPU is still blocked off and unavailable to anyone else. With WoolyAI Hypervisor, users can run PyTorch or VLLM with GPU acceleration on their CPU-only laptops, desktops, VMs. No GPU required. Here's how it works. The users run their CUDA workloads inside WoolyAI client containers running on CPU-only infrastructure. WoolyAI client runtime send the CUDA kernels represented as WoolyAI instruction set to remote GPU nodes running the WoolyAI server hypervisor. On the GPU node, the WoolyAI server just-in-time compiles the kernels into native NVIDIA or AMD instructions, using the vendor's runtime and drivers. This preserves hardware-specific optimizations, delivering near-native performance. At the same time, the WoolyAI server hypervisor manages GPU cores and VRAM dynamically across multiple workloads on the same GPU. It packs workloads more densely, while enforcing fairness and priority-based scheduling. Here are the key benefits of running PyTorch and inference development and test environments outside of the GPU hosts with WoolyAI. First, everyone can develop and test CUDA code anywhere, not just on machines with GPUs. Second, developers no longer need to fight with CUDA drivers or align their toolchains to specific GPU versions. Third, it's truly write once, run anywhere. Development feels local, but execution happens remotely on shared GPUs. Fourth, productivity is no longer bottlenecked by scarce GPU-attached hardware. And finally, IT and security teams get stronger control and governance, while developers still enjoy seamless, transparent GPU power. Now, let's jump into a short demo to show you how it works. I started an AWS CPU-only instance. We can see here that in this instance, there is no GPU. I created a container from the WoolyAI Docker container image, and I am going to use this as my PyTorch development environment. This container has WoolyAI compiled PyTorch binary and WoolyAI runtime libraries. In this container, I have a config file inside, specifying the address of the GPU host where the WoolyAI Hypervisor server is running. This is an NVIDIA GH200 single GPU host. I have created a simple PyTorch script that does inference on the Llama 13B model using a CUDA GPU. Let's run this inference script now. Even though my PyTorch environment is configured and executing on a CPU-only instance, PyTorch can access a CUDA-capable GPU device. The device is the WoolyAI abstracted GPU device. The inference is now running on the Remote GPU GPU host, which is running the WoolyAI GPU Hypervisor with the GPU abstraction. We can see that the model is loaded in the GPU VRAM and gets unloaded when the script ends. I can also set up a Jupyter notebook in this CPU-only container environment and execute projects on the Remote GPU. So, this feature enables developers to run PyTorch or CUDA code on their laptop, desktop, or CPU-only VM with no local GPU attached. The machine learning development environments are separated from the GPU infrastructure. They can run on CPU-only infrastructure, while the CUDA kernels execute on remote shared GPU nodes running the WoolyAI Hypervisor. I hope you found this demo helpful, and thanks for your time.